you, everybody. You did very well. I'm very impressed. I think that if anything, I think we did a reasonable job here in telling them, how to choose a site. But I guess you guys want to know what I chose, right? Do you want to know what I chose? Or what we chose?
We want to know why you chose it.
Well, all but they gave the answers already, so I don't really have to, you guys actually gave all the answers. So I don't really have to tell you all these anymore. Can you recognize it? Can anybody recognize this site?
Why don't you use my email photo or something?
I think the emails are at the back.
Okay.
Yeah. So we, after working through for at least a year, through the analysis, and then going to the sites. In fact, initially we went to the desert because, as I said, it was the bullseye. We thought that was the best site because then we can cover everything, spatial, uniform, and everything else. But when we went there, a desert in Australia or anywhere else is not just a desert. There's actually a lot of vegetation there. And one of the lessons that we learned is that even if you use a really long temporal coverage of just standard visible shortwave infrared Landsat TN type bands to actually do your characterization of your site, in the shortwave infrared, which is really important for detecting dry vegetation, you will not be able to separate soil or minerals from dry vegetation. That's one of the big lessons. And one of the very, very important things why we need imaging spectroscopy, or why we need at least bands enough to cover the dry vegetation, especially like a country like ours, where you have 70% arid vegetation, you need cellulose bands to actually try and characterize your landscape better. So all the other things that you guys said, safety, one of the things that Craig always or has said to me quite a few times, nobody should die out there. So imagine you travel 2 days, right? Okay, 1 day to get to the town where you are, and then another day or 2 hours to get to your site. And I don't know whether you saw some of the slides where it says in big signs, road closure sometimes. So there are times of the year you can't even get through. So, and someone actually mentioned the high temperature, and Chris has been up there with me. I think he was frightened by the heat. But there's a very, very important consideration: safety, communication. Imagine, and Kirk talked about. If you want to automate your site, right? Automating the site is really quite important because you don't want to be walking those transects and be tired and trying to go out there every 10 days. How are you going to do that? So automating the site is actually quite important, and one of the things that we hope to be working towards is trying to automate our site. So when you try and automate your site, communication is extremely important. You must be able to send your data that you're collecting on your site to somewhere else, to either via satellite or either via landline, or preferably something more reasonable like a 4G or 3G network. So that's extremely, extremely important. Then the other characteristics of the site, of course, is extremely important. And remember, we're actually trying to calibrate a visible to shortwave infrared site. So uniformity across the whole wavelength range and being able to calibrate across the whole wavelength range is extremely important. And so pinnacles. In fact, I was telling Kirk that we had 5 years ago at the back of our mind already thinking about the dunes, because we have a lot of dunes along the way north to from Perth all the way. We have all these dunes dotted through the landscape all the way up to Exmouth, to the Pilbara and all those areas. But where's the nearest dunes that's big enough and also not many people, nobody's gonna go and do four-wheel driving and all that kind of thing. We went to one of the dunes in Nanseland and we had actually looked at it for a long time. But in the end we decided that the Pinnacles was probably the best area, mainly because even though it's got some elevation, there are some areas that are quite flat. So we could actually go on top of those flat areas and put some sign on. And you will notice that I said that it's actually in the in the Crown Land. Important for that is that there will be rangers wandering around to make sure that nobody vandalizes our site. We are going to put hundreds of thousands of dollars of equipment on the site. We don't want somebody to go, oh, this is a nice solar panel, I'm going to take that. You don't want that to happen. Also, the important thing is that there are some equipment that don't necessarily have to actually be on the site itself. There are some equipment that actually that can actually go some ways up the site. And that's why I pointed out to you guys that, remember there's this bitumized area or tarred area that's actually the discovery center for the national park. You can place those areas, and those areas are actually locked. So our instrument can go there and nobody's going to steal them. That's one of the rationale for us going there. The important thing, and Kurt pointed out, why did you take my photos of the emus, is that if we take international visitors out there, they're going to have something to look at besides the sand dune. There's nice pinnacles, there's emus, and every single time that I've taken someone there, there's emus running around. It's actually quite fantastic to see the tourists being amazed by the emus. Okay, so, what happened? Not gonna do it? You ain't gonna do it?
Find another sticker on it.
Well, because that would just need to be switched to project.
As soon as.
Right.
Somehow get switched off.
Yeah.
Ah, stupid.
Cindy, you have it too. You pick it.
I must have picked the
Mine.
thing.
Hey.
of a kick. Okay. When I first started looking for a calibration site, the guy who really egged me on was actually, for those who know, is Charlie Kaufman. G knows who he is. Charlie Kaufman was the principal investigator or scientific investigator for the NMAP mission, and he said, "Can you help me look for a calibration site for?" And I said, "Yes, of course. I'd like to. I'd love to do that." And he said, "These are the criteria. I want a high reflectance, pure quartz sand site, and it must not have any other features because quartz has no features at all in any of the visible shortwave infrared range." So okay, well, that's a bit of a challenge, but I'll try. So I got all this sand from everywhere, and luckily there was this competition of the whitest sand in Australia. So can you imagine this crazy soil scientists decided to do this experiment. So they all got all these sands from all the nice beaches in Australia, and I got the samples from them. I measured the spectra and everything, and Wiley Bay or Lucky Bay in Esperance came out to be the whitest, and sure enough, it was pure quartz sand. It was beautiful. It was 80% reflectance target, right? And it was pure quartz sand. And Charlie, I found a site, and but we went there, and you saw Wiley Bay. It's beautiful. It's a beautiful site. If I was a tourist, I'd rather go there. But then what really hit us was the rainfall. It actually is in a very high rainfall zone. So you can't actually have pure quartz, no other features, and no rainfall. That doesn't exist. So there's no perfect site. So you have to really balance out what are you willing to give away, and what would you do to compensate for it. So I don't know whether anybody here actually used the aster imagery that I showed, that I gave to you, besides Pilong, who I know is a aster fan. But this is really to show to you that the composition of the site in terms of imaging spectroscopy is also very important. So knowing that it is of uniform composition was also important for us. So that's why we also use the aster imagery to determine the mineralogical composition. So for the clinical side, there's really two demarcations. This area of very high quartz, or the whole area is very high quartz content, but there are big patches of high carbonate content, and of course the whole area is full of silica sand, and then there's small areas of some clays, but this area here is actually where the pinnacles are. So these are the tourist areas, but we go into the blue area. So remember, we are walking 1 kilometer away from the tourist area, and of course you guys already pointed out that it's pretty reasonable in terms of spatial homogeneity. It's pretty spatially homogeneous from the visible to the shortwave infrared, and it's got low variability between dates. Those are important things. The thing that hit us a little bit that I wasn't so sure about is that there's a little bit of topography. So we need to work on that. We need to find areas that are flat, and we think we can. But we also trying to collect some data to understand better what the BRDF characteristics of the area is. Okay. we didn't actually just choose. What did I do? We didn't actually. We don't just have the one side. Historically, we've always had Lake Lefroy. Lake Lefroy mainly because the group that I work in historically is very much a geoscience-based group. There are a bunch of geologists besides the two environmental people, me and him. Okay, so the areas that we know of and that we can access easily is Kalgoorlie. And we know that we can get to this huge lake in the middle of Kalgoorlie. We know the company well, we know that we can access it. We know it's flat, we know that it's good for calibration, especially if you are working in the visible to near-infrared. So that's why we actually historically chose Lake Lefroy as one of our calibration targets. And it's huge. It's actually humongous. And actually, in fact, it's beautiful, isn't it, Chris? I don't know whether Yama-san and Obata-san would say that after how many times now? In the middle of the morning?
Early morning.
Early
Yeah,
morning,
like,
so we have to do the advanced blood calibration. So
yeah.
very early morning.
Too late.
Sorry.
Too early, right?
Yeah.
But also it's actually very, very accessible. Kalgoorlie is a huge mining town. It's got lots of accesses to equipment and stuff like that. You can ship anything to Kalgoorlie and you know you're gonna be able to get it. And you can get cars, you can get four-wheel drives, you can get anything in Kalgoorlie. So it was an easy choice for us at the time. And we're still keeping it because it's a historical site, and you know the historical perspective is still quite important for us. The climate in Kalgoorlie is very important, and we talked about security, right? Security is really important when you have very expensive equipment that you want to make sure that somebody doesn't steal it just because they think the solar panel looks great on their roof and they could actually charge some batteries. So what we did was we negotiated with the mining companies to locate our equipment, the CMEL, the sun photometer, on their lease area. So they're actually under lock gate, so nobody can go in there unless they have permission from the company. So that's how we try and rationalize that and secure our site. Communication is actually no problem, and we've got all the different permissions.
So what does that mean, restricted areas of fusion? There's some areas that it doesn't work, or like?
Yeah.
Okay.
Yeah, it's a big lake. So there's some areas that you go to that
There's no sun coverage.
there's no coverage.
The mining companies don't use the lake at all.
Yeah.
They're just around it.
Yeah, so the mining companies, like, actually we're a bit worried now, Chris, since you left. They are encroaching on our area because they are actually trying, because there's gold underneath this area and they want to go, and so they are actually encroaching on our area. But the thing, you know, we were thinking of putting some automated radiometric equipment on the lake, and this is where it must go on the lake itself, and we are actually not confident that of the security of putting equipment on the lake itself, so we're still weighing that up. And I guess you saw this, so more or less that's our choice. There's no right answer. You just have to be able to justify, and also more importantly, if you've actually given something away, how can you compensate for it? What kind of measurements do you actually have to make to actually be able to understand what you give away better? Okay?